Yes, you're welcome to our chemistry lessons. In today's video, I want us to look at the carboxylic acids. This is lesson 2. In the previous lesson 1, we had covered the introduction of carboxylic acids. Now we know the functional group in the carboxylic acids. We know the isomerism in the carboxylic acids. We know how we name the carboxylic acids. And for the purpose of our A-level literature, we look at the monocarboxylic acids. The carboxylic acids with only one functional carboxyl group. And in this lesson, we are going to explore some of the methods, theoretically, that we use to prepare the carboxylic acids. And you realize that we have actually looked at these methods in many of the reactions we've been doing in the other homologous series. But for purposes of uniformity, we are going to look at some of these methods in this video, and if there are many, we can still look at more other methods in the upcoming videos. So we shall start with those ones that we are very familiar with. How do we prepare carboxylic acid? Number 1, we are going to begin with oxidation of the primary alcohols. Number 1 is oxidation of primary alcohols. This is a reaction that we saw in the previous videos about reactions of primary alcohols. If a primary alcohol is treated with a suitable oxidizing agent, then it will be oxidized to a carboxylic acid. We say this oxidation is in 2 steps. That the primary alcohol will be first partially oxidized to an aldehyde, which aldehyde can be completely oxidized further to a carboxylic acid if the oxidizing agent is used in much quantities, or if we use a very strong oxidizing agent, the oxidation will take place from primary alcohols direct to carboxylic acid. So we are saying that primary alcohols undergo oxidation when treated with suitable oxidizing agents to form aldehydes, which on further oxidation form carboxylic acids. That means if I had a primary alcohol and I introduce an oxidizing agent, I will symbolize that with letter O, an oxidizing agent. Then we can partially remove some of the hydrogen atoms from the carbon and one from the oxygen atom to form. This is an aldehyde formed after partially oxidizing the primary alcohol. So in presence of more of the oxidizing agent, then complete oxidation occurs. There is complete removal of the remaining hydrogen atoms, and then we shall form a carboxylic acid. So meaning that the oxidation of a primary alcohol to a carboxylic acid is a two-stepwise reaction. First, formation of the aldehyde, and then formation of the carboxylic acid. However, if we simply use the excess of the oxidizing agent, then we can form directly the carboxylic acid. Some of the oxidizing agents used, the common ones, we normally use acidified potassium permanganate solution, and heat. Acidified potassium permanganate solution, we could use acidified potassium dichromate, and heat. So for purposes of writing the equations, we can have an example. That if I had a primary alcohol like ethanol, and we use a dichromate, acidified, and heat, we could form first an aldehyde which will undergo further oxidation in presence of much of the dichromate to give us a carboxylic acid. This can be rewritten as simply use of the excess acidified potassium dichromate, and we heat. The same would be said if we had a primary alcohol. Maybe if we had phenyl methanol, and we use excess. We use excess of acidified potassium permanganate, and we heat. We could form a compound called benzoic acid. The removal of the two hydrogen atoms and this hydrogen atom, that is complete oxidation if we use the excess of the potassium permanganate. So this is one way that we can really use to prepare carboxylic acid. These are simply a few examples I would give, but one thing or one key highlight is that the oxidation occurs in two steps. First, the formation of the aldehyde, and then the formation of the carboxylic acid, which we call complete oxidation. Formation of the aldehyde is partial oxidation because some hydrogen atoms remain on the carbon atom. Complete removal is complete oxidation. And we said this is one of the methods that we can use to prepare carboxylic acids. Other methods that we can use to prepare carboxylic acids, we can have oxidation still, oxidation of alkylobenzene. Number two, oxidation of alkyl benzene. What do we mean by alkyl benzene? If you had benzene ring and there is an alkyl group on it, this is the general structure of alkyl benzene. So what are the key examples of alkyl benzene? We could have as the other group may be as short as just one carbon atom, and that is called methylbenzene. So one of the examples of alkyl benzene is methylbenzene. We could have the more than two. This is another example of alkyl benzene, but it could as well be as branched even. Like this could have been this is the Truman benzene. So all these are examples of alkyl benzene. Now, when alkyl benzene is treated with a strong oxidizing agent like the acidified potassium permanganate, it could be oxidized to benzoic acid. So I'm going to say that alkyl benzene is oxidized to benzoic acid when heated with acidified potassium permanganate solution or potassium dichromate. Solution. These two could be used to oxidize or completely oxidize alkyl benzene to benzoic acid. In other words, we are saying that if I had alkyl benzene and we treat this with acidified potassium permanganate, heat, or it could be acidified potassium dichromate, and we heat. No matter the length of the alkyl group, 2 carbon atoms, branched, 3 carbon atoms, 4, how many? We shall always form benzoic acid. And this is one method that we use to prepare benzoic acid, which is a carboxylic acid. So far we've looked at 2 methods, and both of them are oxidation reactions. The oxidation of a primary alcohol, which we said is a 2-step reaction to the aldehyde and then further to a carboxylic acid and then oxidation of alkyl benzene. But there are other methods still that we have seen. Method number 3, we have seen it still in the previous videos we captured, and this is the acid hydrolysis or acid catalyzed hydrolysis of esters. Number 3. Acid catalyzed hydrolysis of esters. If we had an ester, we have already seen this in alcohols, but we can still have it for purposes of making good work in carboxylic acids. If we had an ester, this is general structure of an ester. I'm distinguishing these 2 arrows by putting prime here. And this is reacted with water, reaction called hydrolysis. but in presence of an acid catalyst, and this is heated. The acid catalyst, in most cases, concentrated sulfuric acid is used here. We said that this would be broken into two at this point here, resulting into the formation of one. From this side we shall form an alcohol, and then the other side we shall form a carboxylic acid. We even explored the mechanisms for this, how this happens, to be able to form the alcohol and the carboxylic acid. So in this case, we are using this method to do the preparation of the carboxylic acid. When we're looking at the preparation of alcohols, we even outlined these mechanisms. In that case, our issue was looking at the preparation of the alcohol. So for us to understand the mechanism for the hydrolysis of these esters to form carboxylic acids, then we need to watch the video about the preparation of alcohols by esterification. And it will give you a clear idea. So here, I'm simply going to give you some examples. If I had, for example, if we had CH3C or CH3, this is an ester, a methyl ethanoate, reacted with water, but in presence of conc, sulfuric acid, and we heat. This ester will be hydrolyzed and broken at this point, such that we have a carboxylic acid called ethanoic acid and another compound called an alcohol methanol. But the important thing here is seeing how we can prepare the carboxylic acids. And then we could have more examples of this, assuming this was from benzoic acid. And we have an ester like that one. You have an ethyl benzoate. This is ethyl benzoate, and we want to hydrolyze this water in presence of conc, sulfuric acid, and we heat. Here, the carboxylic acid is going to be benzoic acid, and the alcohol will be ethanol. So using the acid catalyzed hydrolysis of esters, we can be able to prepare different types of carboxylic acids. Now, another method that we can use to prepare carboxylic acid, and we have already seen this method, is the use of Grignard reagents. When Grignard reagents number 4, Grignard reagent reaction with carbon dioxide. When Grignard reagents are reacted with carbon dioxide, we are capable of forming or synthesizing carboxylic acids with an increase in the carbon chain of the Grignard reagent. We say that if you had a Grignard reagent, because if you have been following us and watching the video, then you will see that we shall be able to read the structure of a Grignard reagent. Grignard reagent, RMGX, if reacted with carbon dioxide in presence of dry ether, we shall be able to form an intermediate. We form an intermediate, RCOOMgX. And this intermediate will be hydrolyzed in presence of an acid catalyst should be able to give us a carboxylic acid. Now in the next video, we shall be now giving more examples on this and the other methods of preparing carboxylic acids. Make sure you don't miss the completion of the preparation of carboxylic acid in the next. Thank you.